Tackling another connected object. We're going to go with the same method that's worked so far. You may know shortcuts or be able to find shortcuts, but the way that I'm doing it will work every time, no matter how weird and complicated I make up the questions. I'm going to start with free body diagrams. For this one, I'm going to start with the 300 gram. I think that one's a little bit simpler. Here's our little free body diagram. Gravity straight down, normal straight up, tension's pulling it forward, and friction's pulling it backward. There's not a lot going on with this one. With the 300 gram, there's nothing weird or vertical, nothing on a funny angle. So I know that normal, boring case, normal is equal to gravity. We could crunch out a number. It was 0.3 kilograms. So 0.3 times 9.8 works out to be 294. Horizontally, this one's a little bit of a different question. It says it's moving at a constant speed. So we could work through F naught equals ma, but really, since it's going at a constant speed, whatever the forward force is, that must completely cancel whatever the backward force is. In this case, there's one of each. The forward force is tension, and the backward force is friction. I know friction is mu times Fn. I know the mu was made up as 0.4. The normal force, we just did math to get the 294. So I know the tension. Tension ends up being 1.18. We'll need that later. Now, kind of like what we were doing before, we're going to press ahead and look at the other object. In this case, it happens to be 500 grams. The free body diagram is a little bit more complicated. We've got an applied force on a funny angle. I'm not sure how big it is, but I know the angle is 45 degrees. I've got a normal force that's up. Sorry, a little bit messy. Gravity straight down. I've got two backwards forces, friction and tension. So a little bit messy, but that's the free body diagram. F applied on a funny angle. Oops. In this case, the F applied is on a 45-degree angle. Two backwards forces, friction and tension. In this case, the unknown is the F applied. For this, we're going to start with the vertical. See if we can narrow down normal a little bit. Doesn't say anything about it flying into the air or falling through the ground, so I'm going to say that the up forces must completely balance the downward forces. I've got two upward forces. The normal is up, and I'm not sure how big it is, but that component of F applied, so this would be opposite the angle, so this is sine 45. So FA sine 45 is another upward force. Those two team up to cancel out gravity. So I won't be able to solve completely, but I can go a little bit farther. The normal force is the force of gravity, mg, minus FA sine 45. mg for this one, it was a made-up mass of 500 grams. That's half a kilogram, so that's 4.9. And I'm just going to leave it as FA sine 45 for now. That's as far as I can go with the vertical component. Usually I can get a number for the normal force. This time I've got that little expression for the normal force. And I'll switch colors. In the horizontal, I kind of have a tug of war, but in this question it was going at a constant speed. So when I look at my free body diagram, make it a little bit bigger. I've got one forward force that's adjacent to the angle, so that's a cosine relationship. And I've got two backwards forces. So kind of like how I said, the F up has to cancel the F down. Well, in this case, or like I said in the last object, the forward force has to completely cancel the backward forces. In this case, there's two. My forward force is FA cos 45. The backward force, there's two of them. Friction plus the tension. FA cos 45, I can't do anything with that. Friction is always mu times Fn. That's, oops, and then plus Ft. Okay, gonna need a little bit more room. Here's what we can do though. I know what the normal force is, so I can sub that in. And I know what the tension is. So I can sub that in as well. I'll crunch away. We will need a calculator to get through this. I'll do it a couple steps at a time. So Fa cos 45 equals the coefficient of friction that I made up was, bring the question back, 0.5. So Fa cos 45 equals 0.5 is a coefficient. The normal force is 4.9 minus Fa sine 45. So I'm going to have to distribute that in there. And then on the end, I have to add the Ft. I'm going to start crunching it out as decimals. I'll carry an extra decimal so I'm not too rough in my answer. But the Fa cos 45 to start off with up here, that turns into 0.707 times Fa. Cosine of 45 is 0.707. When I distribute in, half of 4.9 is 2.45. When I distribute in and do two things, the sine 45 is the 0.707 number. Half of that is roughly 353, also timed Fa. Then on the end, I'm going to finally put in the 1.18. If I clean this up and collect like terms, on the left, I end up with roughly 1 Fa equals 3.63. Getting Fa all by itself, dividing out, I'm going to round it off as well. Works out to roughly 3.4 newtons. This one was a little bit different, but the same process got us through it. Draw the free body diagrams, push them as far as you can go, look for what they have in common.